Hi, I'm Jim Grouch of METSIM Proprietary Limited, and in this short video we'll go through the process of adding another unit operation to our simple METSIM model, and we'll add this additional unit operation upstream of our existing mixer, and then we will change the sequence of the unit operations to optimize the calculation sequence. So first, I'll open the model as we left it from the previous video. And although the model is opened, we can't see anything in the flowsheet drawing area because we saved it in a zoomed in view condition. So I'll use the zoom out tool to redraw the flowsheet to the full extent of the flowsheet drawing area, and we see our previous model. I'm now going to zoom in again, selecting an area that will leave me room to the top and to the left of the existing mixer to add our additional unit operation. So with the zoom in tool activated, the first left click defines the first corner of the zoom view box. The second left click defines the opposite corner, and there we have room for me to put another mix unit operation, a stream coming into it, another stream coming out, which will join into our existing mix unit operation. So to put a mix onto the flow sheet, I'll activate the general unit operation model icons palette and select the mix. The mouse icon changes to show the mix, and left clicking places it on the flowsheet drawing area. I now activate the stream or pipe construction unit operation model and left click to commence the construction of a stream. Select the suggested default stream number and carefully left click again at a valid inlet connection point on the unit operation. Remember, the stream or pipe construction tool is still active, so left clicking again at a valid output point from the unit operation will commence the construction of the next stream. I'll accept the default stream number and left click once and again to create bends in the pipe, and then end by left clicking at a valid inlet connection point. So that's the end of our construction of the new unit operation and streams or pipe for our upstream mixer ahead of our previously existing mixer. And I need to define the stream composition and mass flow for stream for the new inlet to our new unit operation. As previously done, I could use the Edit Object Data tool to enter the total stream flow and composition by component weight fraction, but in this case I'm going to copy the contents of compositional contents of stream 1 to stream 4 using the Copy Object Data tool, which is directly above the Edit Object Data tool, and the Copy Object Data tool looks like two white specification sheets with a red arrow in between indicating the copy-paste behavior of this tool. When the tool is activated, options open for the behavior of the tool. On the first tab, Data Copying, I will change the copy option from being to add to existing data to being to replace the data. In our case, as the new stream has no content, copying, replacing or adding the data will have the same effect, but the replace data option is the one that I use most and am most familiar with. On the second tab switches, for stream values to be copied, I only need to select the component mass flows option. You can see that there are switches also for unit operation, as this copy object data tool can also be used to copy object data for unit operations. So for the stream with component mass flow selected, I will now OK to exit the specification of the copy behavior, and the tool is now active so that an object that I left click on, the data for the object will be copied to the clipboard, and then an object that I right click on, the data will be copied from the METSIM clipboard to that object. In this instance, the object that we are interested in is stream 1 data being copied to stream 4 data. So now I will left click on the number 1 of stream 1, and when I do, we see the color changes to indicate the object data has been copied to the clipboard. Moving across to the number 4 of stream 4 and right clicking, when I right click, the stream color also changes to show that the copy paste sequence has been completed. If I now redraw the flow sheet, I will see the streams change back to the colors which represent the predominant phase that they contain. So redrawing the flow sheet, stream 4 now changes. It was initially red indicating no content, then purple indicating that it was part of the copy paste process, and now pale blue to indicate that it is predominantly aqueous species, aqueous phase, as is stream 1, and this is what we should expect as we have copied the contents from stream 1 to stream 4. Our model is now completely defined, even though we have unit operation 3 added later before unit operation 2 in the main flow sequence, and we are able to calculate the model. But before we do, let's think about what will happen. METSIM is a sequential modular simulator and therefore calculates in the sequence of the unit operations as they're defined in the model. We initially defined mix unit operation 2 and then later added mix unit operation 3, placing it before 2 in the process flow. The calculations will therefore start with the mix unit operation 2, and for the first iteration of the calculation, the content of stream 5 will be 0. Having completed the calculations for unit operation 2, METSIM will then calculate unit operation 3, the next one in the calculation sequence. The contents of stream 5 will then be calculated to be the same as stream 4, and then unit operation 2 will have to recalculate because of the change in content of stream 5 to calculate the new mass balance. And if we calculate the current section, we'll see that this is what happens, although it's too quick to see the iterations that it went through. We do have a valid solution. We have a mass balance and all of the stream contents are correct. Because this is a simple model, the fact that the unit operations are not in the correct sequence may not appear to be a problem. But in larger models with recycles, having unit operations out of sequence can cause convergence problems. Therefore, we want to change the sequence of the unit operations so that the first mix in the process flow is also the first mix in the calculation sequence. To do this, we choose the input drop-down menu option, which is second from the top beside the file. And when we left click on that, looking down at the options, the fourth one from the top is IFLS2, which is used only to rearrange the flow sheet. When we left click on that, we see an array display of our model. We see the unit operation numbers in the sequence they were added to the model or the sequence they were sorted to last. We see the unit operation codes, names if there is one defined, and an array of the input streams, output streams, and the inventory stream number if dynamic modeling is being used. I want to change the sequence so that the mix, which is currently unit operation number 3, is moved up to before the one that is currently unit operation number 2. To move it, I select it with a left click and then use the up arrow, clicking once to move it up one step in the sequence, or move it up one row in the unit operation sequence. The number has not changed yet, but when we press OK, we see the flow sheet is redrawn and the unit operation has been renumbered and is now in the correct sequence of 2 to 3. Now when we calculate the model, the calculation sequence matches the main flow, which optimizes the calculations. The similar process can be applied to controls such as feedback controls and flow rate controls, and the correct definition of the required sequence of calculations can have a major impact on the stability of your model and enable you to implement very sophisticated control strategies easily. Thank you for your time.